In some cases, sorting your data, making them more predictable, might actually make your program faster. But why does predictable data matter? Let's first take a look at what the CPU does when you execute an instruction. Let's say that we have two instructions and we have a CPU with a 5-stage instruction cycle. So first we need to fetch the instruction and then decode it to know what we actually need to do, then do the computation, and then access memory, and then write the result. When we're finished with the first instruction, we start the second instruction and do the same thing. Here the latency is 5 cycles. It takes 5 cycles to execute or finish an instruction, and then the throughput is 1 instruction per 5 cycles. So for this time frame, we are executing 1 instruction. We should know that every stage here is done in different parts of the CPU. So when we decode this first instruction, the fetch part is actually doing nothing. When we're doing the computation, the parts doing the fetch and decode are doing nothing. And the same when we do memory and write. So in one cycle, we're only utilizing one part of the CPU. So the CPU does something called pipelining. So instead of doing a single instruction every cycle, it pipelines the next instructions. So here, the latency is still 5 cycles. That is, it takes 5 cycles to finish 1 instruction, but we've increased the throughput from 1 instruction per 5 cycles to 2 instructions per 5 cycles. And by increasing the throughput, we reduce the amount of time it takes to finish 2 instructions. Here it takes 6 cycles to finish 2 instructions, whereas before it took 10 cycles to finish 2 instructions. But the thing with pipelining is that we assume that the next instructions can be executed before finishing the first instruction, which means that, for example, if I2 depends on data which is the result of I1, well, we can't really pipeline it. So data dependency is one of the problems with pipelining, but another is branches. So when we have a branch here, if I is lower than the length of B, before executing this part, we need to wait for this part to finish. So how does the CPU deal with this? Well, there's something called the branch predictor. Instead of waiting for this, the CPU will predict whether the branch is taken or not taken. Now this is great for loops. In a large loop, this is an always taken branch. So let's say in the first iteration, this is true, and then we execute this, and then in the next iteration, let's say we have a length of 100. This is true again, and we execute this. And then let's say for 10 iterations, this is always true. At some point, the predictor will know that this is an always taken branch. So it will easily know that the next instructions we want is this. However, not all branches are predictable. Here we are iterating over an array, and we can see that the data here, the interval, is not predictable. There's 130, 130, 130, and 1. Let's say that if the interval is 1, it is true, and if it's 30, it's false. In the first iteration, we have 1, which is true. In the next iteration, we have 30, which is false. In the next, we have true. In the next, we have false, and so on and so on. So the problem here is that the branch predictor can't see any pattern. Let's say that the predictor predicts true, so it fetches these instructions. We're doing some work here, but it turns out that the value is actually false. So all the work here we've done is wasted, and we go to here. When the branch predicts that it is actually false, it fetches this instruction. But let's say that it's actually true. We actually don't need this instruction. We actually need this instruction. So all the work done here is wasted, and we need to start here. So the problem with this is that we need to always flush the pipeline when it does a misprediction. We're doing a lot of work that is actually wasted before starting the work that we actually want. So is there a better way of doing this? Well, again, the problem here is that the data is unpredictable. The branch predictor doesn't see any patterns here. So what we can do here, at least in the case when the data is constant, we can do some pre-computation with the data to make it predictable. And in this case, what we can do is actually sort the data. We can sort the thing that we need to be predictable. In this case, it's the interval. So if we sort the interval from lowest to highest, now you would probably want to use qsort or something, but after doing that, the branch predictor can actually detect the pattern here. So when it predicts which instructions to fetch, it is more likely that we're doing the work that we actually want. Now in this case, the array is pretty small, so it's probably not going to really matter, but it will matter more when you have a lot of elements.